Hello, assalamu alaikum guys. Today we are going to be discuss about the concrete properties and its field application. So what concrete is? It's a construction material that widely used in the construction of the building structures. So once we are going to be discuss the building technology, so we must know in detail that which type of the materials we are using to construct a building, so that later on we can go towards its latest technology. So for the material, we will basically going to be used, or in broader category, we are going to be use the concrete and the steel as in construction material. So one by one in today's lecture, in this week we will discuss about the concrete, and the next week we will discuss about the steel material. Obviously, first of all, we will discuss that how this material is going to be manufactured or going to be formed with the help of different ingredients, or if in the factory manufacturing, like steel is manufactured in the industry, so then how it is going to be made. So for the concrete also, what are the basic ingredients, those are going to be used to make that particular material, and then further how structurally it will be efficient to carry the loads within the buildings, so that we can use it as in construction material. That was the one by one and the point that we will discuss in this particular lecture. So the basic ingredients of the concrete material, first of all we will discuss today about the concrete, in which we are going to be use the cement paste, that may be a combination of water plus cement, and finally and the secondly the aggregates. So broadly what you can do, you can divide your concrete into two main ingredients. Those will be the cement paste. The cement paste, in many of the literature you can also find it as a matrix. Okay, so matrix is just the water and plus cement. This is a matrix. So matrix is a combination of water and cement only, and your aggregates are the coarse and the fine aggregates. So in coarse aggregates you can find out the main aggregates, those are the larger in sizes, and in fine aggregates mostly we are going to be use the sand, okay, with a different type of the sand particle sizes. The sand particle sizes may be different for the different type of the sands, and for the coarse aggregates also different. Okay, out of these all ingredients, your cement basically is going to be manufactured in the industry, and your coarse aggregates are found out by the different quarries, okay, from the mountains. You can say different hills be there, different sources be there. From there the rocks are going to be used as an aggregates, and those are going to be crushed in the form of these sizes. And what about your sand? Sand is also going to be formed from the riverbeds. Okay, so the sources are different. This is also a very, you can say, a big industry in which the sand has been collected from the riverbeds, and then those are sold from the different sources. And again the coarse aggregates also going to be taken up from the different quarries, different sources, and then those are crushed with the help of crushers, larger crushers, and those are again sold to make your concrete itself. And cement is also going to be made or the manufactured in the industry. The water is available in abundance in all of the time, and also the different various type of the quality is required to use in the concrete to mix all of these ingredients. So the after the ingredients, the you can say the very basic thing is that how to mix those. So in the coming slide, first of all we will discuss one by one about the cement, about the aggregate, about the water quality. Okay, and then later on we will discuss about its mixing, its batching, and then finally how to cast the concrete to make your structural components. So once we talk about the aggregates, so your construction aggregates or simply aggregates is a broad category of the coarse particulate materials used in construction, including sand, gravel, crushed stone, slag recycled concrete, and geosynthetic aggregates. Aggregates are the most mined material in the world. So can you see over there? So these are mined from the rocks, and then the crushers are involved over there, and these crushers are used to crush in different sizes. So you can see here the sizes are larger, here the size is smaller. So with different or the various sizes, those are going to be crushed at the site, and then those are transported towards the construction site or towards the wholesaler, so that we can get from there. Aggregates are generally derived from the igneous or sedimentary or the metamorphic rocks, or from the recycled and processed industrial byproducts. So these are the various sources also. If the rocks are involved, then the igneous, sedimentary and metamorphic rocks, those are going to be of course going to be affect the properties of the aggregate itself. And also from the recycled you can say concrete, okay, you can use it, and also from the processed industrial byproducts you can use. So whatever the source is, first of all, before using it as an ingredients for the concrete or the mixing, we have to check their properties. Okay, there are different various tests, those are needed to be performed before using these aggregates to test their strength, okay, in many ways. 65 to 80% volume of the concrete is the aggregate, so it's very important. The aggregates are very important ingredient. Aggregates were considered as a chemically inert, most of the cases, 99%. But 1% possibility is that, depending upon their sources, of course, that they have revealed that they may also react chemically. So classification of the aggregate based on different factors. Those are natural and the artificial aggregates. Those may be coarse and the fine aggregates, as I have told you. Round, based on shape, irregular, angular or flaky type of the aggregates. You may have uniformly graded or the well graded aggregates. Okay, so well graded mean that almost all of the sizes within one mix are almost same. So uniform graded mean that they may have the different type of the sizes also. So you have these figures are going to show you the distribution of the particles, mean your cement. If this is the total concrete mix, then you can see over here, this is the Portland cement and water. This is the matrix, all of this grayish area. Okay, so this all grayish area is going to show you the matrix. The matrix is just the water and cement, and rest is going to show you the larger particles are going to show you the aggregates, coarse aggregates, and the smaller particles are going to show you the fine aggregates. Okay, so this whitish area. So here also you can see here the fine aggregates are also going to give you very small particles, and here you have the larger particles going to show you the aggregates, coarse aggregates. In the next slide, we talk about the sieving process. This is the US standard sieve sizes. So your sieving is used to just to categorize your aggregates based on their particle size. Okay, so a typical sieve used, this in this figure at the top you can see the sieve. This is a typical sieve that is used for grading of the soil particles in geotechnical laboratories, and is also used for grading of the aggregates in concrete testing laboratories. So number 4 sieve has wires spaced at 1/4 of an inch, that is approximately equal to 6.4 millimeter on center, and a number 10 sieve has wires at 1/10 of an inch, that is approximately 2.56 millimeter on center. Clear space between the wire number sieve number 4 is 4.75 millimeter, and that of number 10 is 2 millimeters, and depending upon all other sieve sizes in this table is written. If your sieve size is number 4, then its opening size in inches is 0.187, and in millimeters it's 4.75. Mean all of the particles, those are greater than 4.75 millimeter, will rest on that particular sieve, and having sizes less than 4.75 millimeter will pass through that particular sieve. Then you have sieve number 6. It has much more smaller as compared to sieve number 4. It's 3.36. Okay, so if you go on further reducing the dia of the sieve, increasing the number of the sieve, then the spacing is, or the opening is going to be decreased. You can see over there. So very, very small sizes can be sieved out, can be taken out, and you can use for your construction purpose. So whatever the dia is required, so keeping on that particular range, let's suppose if we require the diameter that range between these two sieves, so we can use this 0.59 sieve. The particles retaining on this will be greater than that, and past will be smaller than that. So we can get all of the particle size, those is going to be in between these two sieve number 20 or 30. So in this way we can take out sieve out our particle sizes. So here you can also see a graph. This is the increasing particle sizes in order, you can see in this way. So here you have the 0.002 millimeter sieve size. Okay, here you have 0.00 sieve size, sieve number is 200, so 0.0075, 0.075, sieve number 4, 4.75, and here you have larger 3 inches. Okay, so if we talk about this range, so sieve number 200 is going to be make a boundary for the silt and for the clay. Okay, so all of the particles, those are going to pass through sieve number 200. Those will be cohesive soils, silt or clay. So generally, and most of the cases, we are not going to be use the cohesive soils for the construction purpose. We are always going to be use the non-cohesive soils for the construction purposes, as in our ingredient in the concrete. So all of the particles retaining on the sieve number 200, we are going to be collecting out, going to be used. Then out of those particles retaining on sieve number 200 and passing through sieve number 4 will be equal to sand. Those will be the sand particles. So those particles retaining on sieve number 4 will be gravels. Okay, so mean the larger size particles. So if 3 inch is the size, so more than that it will be cobbles or it will be boulders. So keeping the 3 inch to 75 millimeter and 4.75 millimeter will be the coarse aggregates, and from 4.75 millimeter to 0.075 millimeter will be the sand particles. That will be fine aggregates. So it will be coarse aggregate sizes, and here we have the fine aggregate sizes. So depending upon those, we are going to be selecting out or grading out. This is called grading. Okay, so how you are going to be grading, do the grading for the sizes of your particles. This is another chart that is for your information. You can see it by yourself. This is another one that is from the ASTM standard grading requirement for the coarse aggregate. You can see it by yourself. So here you can see it is ASTM C33. This is the code for the concrete. So next is the size of the coarse aggregate. Depends upon how to decide about the size of the coarse aggregate from the range in which the coarse aggregates are available. So it depends upon the size of the structural member and the spacing of the steel reinforcement. It depends upon the maximum size of the aggregate should be smaller than the thickness of the structural member. Okay, so let's suppose if you are considering the 3 inch size of your aggregate and you are placing the steel inside the concrete. Let's suppose you are casting a slab, and the spacing between the steel for this particular slab, here the meshing is done. Here we have going to be placing the steel bars. So if the distance between the steel bars are less than 3 inches, let's suppose it is 2.5 of an inch. So this 3 inch larger boulder size, or you can say the aggregate size, is going to be make an hindrance over there. Okay, so we have to use the coarse aggregate size at least, keeping the steel reinforcement spacing in our mind. So if it will be 2.5 inches, so less than that we have to use the size for the coarse aggregate, so that in between the two wires those aggregates will be remaining in contact. Then comes the lime. Lime is actually not used directly in nowadays, but if we go towards the history of the cement, then this lime material is very important. Okay, so here also written in the statement that until the invention of the Portland cement, lime was used as a binder. Okay, Egyptian used lime, sand, mortar in construction of the pyramids. The later on slides, depending upon you for the clearing about the lime and further how the lime is going to be used, going to be moved towards the cement production, that you have to be studied by yourself. Okay, this slide for about the lime. Next one is about the chemistry of the lime, how calcination of the limestone occurs, how hydration of the quick lime, and then further the back procedure, that is carbonation of the hydrated lime. That you have to read by yourself. This is also a cycle that is going to show you the calcination reaction, then hydration reaction, and then carbonation reaction. So in a very simpler way it has been described over here. Okay, so if you have a limestone that is having the calcium carbonate inside of it, if it is heated, okay, so what is going to be happened? This is called as calcination reaction, and you will get the carbon dioxide produced as a result. So if further this carbon dioxide gas is going, I mean you have the quick lime Ca, and also CaO has been produced. Okay, so if CaO is going to be mixed with the water, then it is called as hydration process, and as return of this procedure CaOH is produced. This is called hydrated lime or calcium hydroxide. So and also heat produced. So if this hydrated lime is reacted with the carbon dioxide again, then it is going to give you again the lime. You can back recycle the limestone again. So in this way the water is going to be produced. Okay, so as an as in your product. So finally you are getting your limestone again. Okay, so this is the simple procedure. Then comes hardening of the lime. Pozzolana or pozzolanic material, what is that? You have to read it by yourself. Types of lime used in construction. What is cement and its history? Chemical composition of raw material used to manufacture a cement. Here also in a table form, the composition in terms of percentages are written. Then manufacturing process. It's very briefly written over here, in which you are first of all acquiring the raw material from different sources. Then you are grinding it or crushing it out of the raw materials, either dry or wet process. Calcining in rotatory kilns at a very higher temperatures, 1000 to 1900 degrees centigrade. Clinkers formed. Then addition and blending of the gypsum while grinding clinker. Finally, the cement has been formed and you need to be packed the cement. This is the figure that is going to show you industrial procedure, how the cement has been manufactured. So finally you are getting your cement in packed form as these bags. You can see like different industries are going to give you the different names for like Parkland Lines, the Flying Pakistan, the Tata Cement, okay, and many others. Then we have composition of cement clinker. You can also see it by yourself. Again over here in the form of pie chart, this distribution has been given. Then comes hydration of the cement. Once cement is with you, then the water causes the hydration of the concrete through a process called hydration, as I have told you earlier. So what hydration is, if you have CaO within your material, like your cement, then it is reacted with the water. Then it is going to give you the CaOH twice. CaOH mean calcium hydroxides. So those are the main, you can say, a strengthening element within the cement. Those are going to make hard your cement, and finally you will get strength out of cement. So your hydration is a chemical reaction in which the major components or the compounds in the cement form the chemical bonds with the water molecules and become hydrates and hydration products. Okay, this is called CaOH twice is called as a hydration products. Okay, so if silica is present, then silica hydroxide is formed. If magnesium is present, then magnesium hydroxide is formed. If calcium is present, then calcium hydroxide is formed. So finally you are getting hydration products. Those are going to give the final strength to the cement. So in this slide also written, if you have a tricalcium silicates it is hydrated with the water. So you are getting C3S2H, mean calcium hydroxides are formed. Okay, so these are the hydrated form. If you have the dicalcium silicates, then again you get this calcium hydroxides. If you have tricalcium aluminate, then you get the ettringate, this is very important component. Those are going to give the strength to the cement. Okay, so in this way the different type of the composite type of the also present compounds, those are going to give you finally the hydroxides. So you can see the binding effect. So your figure number A is going to show you the phase when it is immediately after the mixing, mean hydration has not done. So slowly once hydration has been done, then your unhydrated cement particles are going to be form a gel finally. Okay, so this gel is going to be formed here, you can see. So if the cement particles, these are unhydrated cement particles in this figure, those are going to be shown like this. So these unhydrated cement particles slowly are going to be form a gel. Those are in expansion form. Okay, once it is going to be reacted with the water. So your hydrated products are going to give you a certain this type of the composition of the matrix that is going to give you the finally give you a capillary pores and cavities, and finally those are going to be interacted with the coarse aggregates, later on the other sand particles. Okay, so in this way it is going to be form a gel, and in all of the directions this cement is going to make that particular gel, and these hydrated components are going to give you a strengthen, mean going to be binded with the other type of the ingredients like coarse aggregate and sand aggregates. So finally your gel is going to be infill, and finally the hardening is done. So hardening is very important for the cement, and 128 days has been done, then you will get the final compressive strength depending upon the final hardening of the cement due to the hydrated compounds made due to hydration process. So what does it mean? To complete all of this procedure from point A, figure A to D, okay, to make this kind of the hydrated or the binded form of the cement, you need the water. Okay, so throughout these 28 days, throughout this hardening process, this hardening process of the cement required water to complete the hydration process. So here you have a graph that is going to show you with different type of the hydrated compounds, you will get the increase in the compressive strength. So whatever the point is that your compressive strength is going to be increased with the age. If you have 28 days, then you have 90 days, then you have 180 days. So further and later on the strength is going to be increased due to hydration process. As I have told you, the water requirement for the hydration is significant as cement sits and hardens by the reaction with the water. Water in cementitious material will be either free or the bounded water. Free and bound water can be said as evaporable and non-evaporable water respectively. So 35 to 40% of the water by mass of the cement required for the hydration. That's very important. Depending upon that, we are going to be decide about the water cement ratio. Okay, so we may have the water cement ratio, and it give you finally, if you are multiplying with the ratios for the normal concrete, generally it kept as 0.4, okay, to 0.5 for the normal strength concrete, and for the high strength concrete and special type of the concrete, they may kept as 0.18 to 0.3. Okay, for normal concrete generally it kept is like that. So if the cement contents are with you, you can multiply with the water cement ratio, and the amount of the water you can calculate for the hydration process. Then you have different types of the cements depending upon your specifications. ASTM C 150 gives you the standard specification for the Portland cement. ASTM C 595 will give you the specification for blended hydraulic cements. The ASTM C 1157 will give you the performance specification for the hydraulic cements. So one by one in ASTM C 150. So you have type 1, you have type 1A, you have type 2, that you can read by yourself, all of the types in ASTM C 150. And in the later slides, you can see the type 1. This is general purpose use concrete. Okay, its properties are given over here, that where you are going to be used. Similarly for type 2, it's moderate sulfate resisting cement depending upon the type of the cement. Type 3 is high early strength, that you can read by yourself. Type 4 is low heat of hydration cement. Type 5 is high sulfate resistant cement. Then you have air entraining Portland cement. Then you may have white Portland cements. ASTM C595 give you type IS, type IP, type P, type I, type S and type ISM. So depending upon all of the definitions are given. So ASTM C1157 includes type GU, HE, MS, HS, MH and LH. So depending upon all of the definitions are given, and its detail is also given in coming slides. You can read it by yourself. Now water for the concrete. What properties are required for the water used in a concrete? That is a very well known you can say statement, that water fit for drinking is fit for the concrete. So usually our engineer says that. So that water you consider fit for the drinking purpose, that is also fit for the concrete. Okay, so mean no extra salts should not be there, any contamination should not be there. So whatever the quality of the water you are considering, that is very good and suitable for drinking purpose, that is also fit and suitable for the concreting purpose. So it should be free from the dissolved salts. It's very you can say hazardous, because it can react with the cement and can cause the efficiency of the cement to develop the strength of the concrete. So it must be clean, no dirty spaces or no other suspended particles should be there within the water. So now start with the properties of the fresh concrete. So once it has been mixed, all of the ingredients are going to be mixed with a certain ratios. So let's suppose if we have designed, design is not a scope over here, that how to design the mixed ratio for the different ingredients. But let's suppose we are going to be, any engineer is there and he has designed, civil engineer, he has designed that your concrete for that particular component of the structure for this particular building is requiring the ratio as 1:2:4. This design mix ratio mean that 1 is for cement, 2 is for sand and 4 is for aggregate. CSA, that formula you have to remember. CSA, 1 is for cement, 2 is for sand and 4 is for aggregates. Okay, so if this is the particular case, then your one part, if one part cement is going to be used, then sand is used and double than that. The aggregates are used 4 times to the cement part of it. So if 1 kg cement is used, let's suppose, then 2 kg of sand needed to be mixed with that particular cement and 4 kg of the coarse aggregate should be used. Then the water is going to be calculated depending upon water cement ratio, as I have told you. Depending upon your requirement, you are, let's suppose, specifying your water cement ratio as 0.35, let's suppose. The cement components is with you. You are multiplying it with the water cement ratio and you can get the amount of the water. So for the mixing purpose, these 3 ingredients measurements are very important. Okay, so quantity is very important. In how much quantity you are using the cement, and then in how much quantity you are using the sand, mixing the sand, and then in how much quantity you are mixing the aggregates and the amount of the water. Okay, so once you have to do the mixing, mean mixed ratio, design the mixed ratio. After designing the mixed ratios, you have to find out the quantities. So this procedure to find out the quantities out of this design mixed ratio formula is called as batching. What is batching? Batching is that to calculate or to take out, to measure, to weigh the quantities of the cement, sand, coarse aggregate and water depending upon the water cement this mixed design formula. Okay, these ratios. So whatever the ratios has been designed, depending upon these ratios, you have to find out the batching. Okay, that if in a certain mixer the volume is, let's suppose, 1 liter, 1 liter is the volume, then by volume you have to calculate that out of, depending upon this design mix ratio, which is the what is the quantity of the sand and cement and coarse aggregate and water is needed to be used to use this kind of a mixer having a capacity of 1 liter. This is called as batching. That need a certain simple calculations. Okay, there is no, you can say, technicality is involved over there. Just the design mix formula is with you, ratios are with you. Out of these ratios, the quantities needed to be calculated, and these quantifying technique is going to be called as batching of the concrete. So very first you can say procedure for the concreting is in concrete processes. The first one is that you are going to be define the materials or the ingredients used to make a concrete. Which kind of the material we are going to be using depending upon our requirement for our building a certain structure. Then number 2 is, if materials are with you and its properties you have determined earlier, then what you have to do, you have to do the mixing, mean design mix you have to form. And then third is the batching. Quantity you have to define, you have to calculate. And then finally you are using a mixer to mix it. So once the mixing has been done, then you have a fresh concrete with you. Okay, now this fresh concrete, before pouring or before casting on site for your building project, first of all you have to determine its certain properties. Okay, you have to perform a certain test on site or in the lab. So these are going to be called as the very, you can say, a basic or very important test that need not to be missed in the field, that is called as workability. That is, what is workability of the fresh concrete? It is the ease in placement while retaining its homogeneity. That is termed as workability of the concrete. Workable concrete is obtained by the use of the well-graded aggregates. Sufficient amount of the fines sand from the river beds yields more workable concrete as compared to the sand obtained from the crushing stones. 2 angular coarse aggregates reduce the workability. Adequate amount of the water needed to be used. So workability means that if you are not going to be specify the sufficient amount of the water, okay, then during the hydration process all of the water has been used by the cement to make the hydrated products, then finally you are not going to be left with the certain water to make it easy to workable, to place on the for the concrete side. Should be flowable. Okay, your concrete should be workable, should be flowable enough so that easily it can be placed on the site. So if it is not happening, then you have to be redesign this mixing procedure, mean the water amount you have to be recalculate so that your mix or your fresh concrete should be workable enough. So to test the workability of the cement, that it is suitable to place the different structural components on the site, you need a test that is called as SLUMP test. This is followed by the ASTM C143. SLUMP test is a measure of the workability of the fresh concrete that is performed using a truncated cone and a steel rod of 5 by 8 inch of the diameter. So here you can see this rod, okay, that is going to be having a certain larger diameter at the bottom and smaller diameter at the top. So what we can do, you can place our concrete that has been mixed in fresh form inside of this cone, and then we are just keeping up, just taking up this cone and leaving all of the material, concrete material inside of it. So once we are just taking out of the cone, okay, in upside direction, then whatever the material has been left, it is tends to be moved down. Okay, so in whatever height it is dropped, okay, due to this, it is from the top of actual, you can say the 3 centimeter is the actual height of this cone. So this height of the cone, that was the original, okay, as an initial, that can be 0. So from there, how much drop down has been done for the material, it is going to be called as slump. That slump is needed to be measured by placing a scale over there, okay, with the help of the scale from the top of the dropped material till the original height of the cone. This distance is measured, and then later on in the ASTM standard, it's given that what should be the suitable value of this drop of the material from the cone, and that is needed to be compared with the values given in the standard. So you are going to be filling your material in the slump cone in the form of layers. The steel rod is going to be used just to be compact the material, so that it uniformly material is going to be, concrete is going to be filled within by the cone. So once you are taking out the cone, so it has been dropped from the top side, we are going to be measured this slump. Okay, so this slump is going to be measured like this, and this is going to give you the certain ranges. So if the slump is 4 to 5 inches, recommended, very suitable for walls and columns concrete, and 4 to 5 inches is considered very suitable for the beams, the concrete used for the beam casting, and 3 to 4 inches are used for the slab. Okay, so in this way you are going to be using these values by the standards and comparing your own. So if it is not going to be in that particular range, then you have to revise. I mean, again, the mixed design you have to revise. Another problem after casting the concrete you may observe, that is called as segregation and bleeding, in which once the concrete has been casted, so you can see the water coming out of the surface. Okay, that is bleed out from inside of the material. You can see all of the shining surface. The shiny surface is due to the water that is coming out from the material, the concrete itself, after casting. So this occurs due to the improper placing, giving a non-homogeneous concrete, thereby reducing the strength. So bleeding is rising of the water on top of the concrete surface. That should not be done. That is not beneficial for the concrete. So generally we are going to be mixed properly. Homogeneous mixing is required. So if there is a problem during the mixing, then what is going to be happened? The cement and all the ingredients are not mixed properly, and they are going to be left the spaces in between, and from those spaces the water come out on the surface. Then hardened properties of the concrete. So once after 28 days strength, you have done the curing, and then your concrete has been you can say strengthened, then what you have to done for the hardened concrete, you have to find out the strength and durability. The compressive strength is very important. That is done for the concrete, followed by ASTM C39, in which the cylinders are cast with the same dimension. This is the standard dimension. You are not going to vary these dimensions. That is 12-inch height of the cylinder and 6 inches the dia of the cylinder. So you can see over here these yellow color cylinders. So we are going to be fill on the side. Whatever the concrete we have filled in the beams or in the columns, the same on the same day and the same time we are filling in these cylinders. So after 28 days, we are also going to be test these cylinders, that whether those are going to give you the same strength or not. So your actual structure will also going to give you the same strength as casted by the cylinder on the side. So these are going to be compressed within that particular machine. You can see this is the load platen, and these cylinders are placed over there, and the load has been applied with the help of this machine in compression, and then finally it is crushed. So the crushed strength has been declared as its compressive strength, and this is going to be give you after 28 days. Then, as I have told you, preparation of the concrete by mixing the ingredients using a shovel, by using on-site mobile concrete mixers. The batching plant and transporting is required. Here is a mass concreting. if the very large scale of the mega structures are needed to be built, so for that particular case we need a very large plants. Those are going to be called as batching plants. So these batching plants are going to be give you the aggregates, measured quantities of the aggregates, the fine aggregates, the cement separately, and then from these larger containers, with the help of the conveyor belts, those are transported towards the particular point where it is needed to be casted. So there the mixers are involved over there. So here you can see the mixers, trucks. So those are waiting to be charged with the mix, and then finally those are going to be carried towards the site where it is needed to be transported. So this is the fine aggregate source, these are the coarse aggregate sources. Those are carried towards these containers and then finally mixed together. So here you can see from the conveyor, from the containers, okay, those are materials independently are going to be putting inside the tanks, okay, mixers. So from here also it is going to be taken inside the mixer, and from the third one also, and finally the cement, coarse aggregate and fine aggregates are mixed in this tank, and the water is also inserted, and finally those are going to be mixed until those are reached towards the site. So mixing has been done side by side. Then come placing of the concrete. After preparation and reaching at the site, it should be placed, the concrete should be placed as early as possible, because the hardening procedure has been started. So we do not need much more delay. It transport the mixer or the truck, if the transport mixer or the mixer truck can be placed nearly to the pouring site, it can be placed using chutes. So chutes are the simple, you can say a kind of transportation mechanism in which the concrete has been placed towards the particular site where it is needed. And before pouring of the concrete or casting of the concrete, the steel needed to be embedded. So you can see this is the first step. The required steel, you can say, design has been done, and whatever the shape and the orientation of the steel material is there, that steel is needed to be binded over there, placed over there. And once steel has been done, steel you can say all binded over there, then you are going to be pouring your concrete inside of it. Placing or pouring can also be done using buckets. So in that particular form, from the mixer, the concrete has been transferred towards certain buckets, and those buckets are carried out towards the required places, okay, and then it has been poured. And for again the mass concreting in mega projects, the concrete pumping has been done for pouring in case of the mass concreting. So here you can see that you have the concrete pumped through a pipe, and then it has been poured. Okay, so concrete final destination is this one. So here you have pump trucks. So pump trucks are pumping from the mixer. This is the mixer truck. So from the mixer truck, through pumping action, the concrete has been carried out towards the destination. Then comes concrete consolidation. Concrete consolidation is required the proper, you can say, mixing or you can say placing of the concrete. If voids has been left, then it is not suitable. I have told you that is going to be caused the bleeding of the concrete. So the consolidation means that we are going to be eliminating the voids while placing the concrete on the site. So it can be done using a steel rod, vibrator, inserted in freshly placed concrete, or by vibrating the formwork itself. So this is the formwork that has been done. That is the kind of a wooden formwork that is in between the shape of the concrete has been maintained. Okay. So we are going to be placing the concrete in between the formwork. So this formwork is kind of a mold, so that the shape of the concrete has been maintained depending upon the structural components that has been formed at the end. So it's kind of a mold. So formwork has been placed over there. Between the formwork we are placing the concrete. So what we can do, we can vibrate this formwork. We can use the vibrator inside the concrete, or we can use certain steel rods to compact it. Okay, so this compaction and consolidation is very important. Excessive vibration should be avoided, just to avoid, just to remove the air bubbles inside the concrete material. That is enough. Then comes finishing concrete surface. So you have skidding and striking off, you can floating or dabbing you can use, and troweling you can use. So it's okay. So if the surface is needed, you have poured the concrete, but the surface is needed to be make a plain surface. So for that particular case, you are using that kind of the troweling. Okay. So larger, you can say the wooden Plates can be used to travel purpose, and you can use a ribbing, you can use the floating mechanisms, you can use the striking off mechanism. These mechanisms you can see in literature in detail by yourself. Here also in figures, floating and ribbing. This is traveling. So finally, water requirement. As I have told you, 0.3 to 0.45 cement ratio has been used. Generally, water cement ratio is ordinary. Concrete is 0.55 to 0.6. I have told you. Excessive water is required to achieve the workability. Approximately 80% of hydration is completed in 28 days. So 2/3 of the 28 days strength is achieved in 14 days and half in the first days. This is very important. Total strength, required strength, this 2/3 of this has been achieved in 14 days and half in first 7 days. That's very important that at the initial stages of the concrete, out of the 28 days, the very first 7 days are very important, okay, for the water hydration process. So approximately 80% of the hydration process is completed in complete 28 days. So complete the hydration process, the water is needed to be in contact with the water all the time. The water should be available throughout these 28 days with the cement so that it can react with the water and it can get strengthened. So for that particular purpose, we need curing of the concrete. Hydration of the cement continues in the presence of the moisture. So in case of the moisture is lost or evaporated, hydration and hence strength gains ceases. So curing of the concrete is defined as providing adequate moisture, temperature, and time to allow the concrete to achieve the desired properties for its intended use. So this is very important. Curing is done by keeping concrete surface wet with the water, covering the concrete with the plastic sheet so that already present water cannot be evaporated, using curing compounds. There are so many curing techniques that we are not going to be covering over here because of the time limitations. But for your interest, you can see, and you can also see the literature for that, and you can search the internet because most of the modern techniques for the curing are developed nowadays. This you can read by yourself, hot and cold weather concreting. So coming towards the high strength concrete, the conventional concrete or the normal concrete have a compressive strength, 28 days compressive strength less than 6000 psi, and high strength concrete have the compressive strength more than 6000 psi. There is no exact separation between these two types of the concrete, but anyhow we can have this idea of 6000 psi. High strength concrete is produced by using admixtures and pozzolanic or the mineral additions in concrete other than the simply water cement and the aggregates. Admixtures. These are the chemicals added to the concrete mortar or the grout at the time of the mixing to modify the properties either in wet state, immediately after the mixing, or after the mix has been hardened. So again, in detail we are not discussing that which type of that mixture and chemicals are used. If you are interested, you can search it by yourself, but you have to keep in your mind that to make an high strength concrete, another ingredient is used that is called admixtures. Those are chemically is going to be improve the quality or properties of the concrete. Here types of the admixtures are enlisted. Now pozzolanic additions mean having silica contents in it. Pozzolan, we are going to say those materials in pozzolanic materials, those are going to be having silica as in must components into it. So fly ash is the waste product produced by the coal fired by the power stations. Okay, so from the coal power plants, in the base of the kilns or the rotatory kilns, we are getting the ash, and that ash is going to be called as fly ash. This is very fine powder, blackish powder, that is going to be added into the cement to improve its properties. Fly ash particles in concrete densify the concrete, filling the voids between the cement particles. During manufacture of the cement, a certain amount of the lime does not convert to complex cement compounds, termed as free lime. Fly ash being pozzolanic, it reacts with the free lime, converting it to the cement and hence adds to the concrete strength. So two, you can say, physical action and chemical action. For both physical and chemical reactions and actions and factors are involved to use fly ash to increase the strength of the concrete. Similarly, more you can say finer material is the silica fume, more than finer than the powder. It is the waste product of the silicon industry. It has also an excellent pozzolanic properties. It can react with the cement to make hydration products to make the strength of the concrete. This, like the fly ash, it reacts with the free lime and adds the strength to the concrete. So this is it for the concrete part. Thank you so much, guys.